Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us today to stay curious. We have one of the world's experts on growing food, plants in space, Mr. Gary Stutte. Gary.
Glad to be here, Mark.
Well, we're glad to finally get you here. Gary's a personal friend of mine, and he's been a friend of the American Space Museum and our director, Karan Conklin, for a long time.
Long time,
20 years or more, right?
At least.
In there. And he is indeed one of the experts. Put your little meme up there. We're going to talk about growing plants in space and feeding people on Earth. Gary, you're a space biologist. You're a consultant. You have your own business, Synergy. And he was on our program. Marty Winkle, my co-producer. Marty, he was here in September 17th, 2020.
Seems a lot. Seems
right.
not done. Time
and
flies.
We're going to see a picture of that. We got our COVID barrier between us and everything. That was probably about episode 150, and we're up to about 760 some episodes, spreading the love out there of the space community.
Yep.
And we're so glad to have you here today, buddy.
We're glad that you keep this up, giving up the history of the space program and how it applies to people's lives and the legacy that we come from.
Well, you're welcome, and it's an honor to do that. Gary's the founder of Synergy, a consulting agency or specializing in space agriculture and controlled environmental agricultural technology. In other words, he's learned about LED lighting, one of the first ones involved with the LED lighting systems. You have over 150 scientific articles published as Dr. Stutte. And of course, everybody wants to know about eating food on the space station, and then how are we going to get to Mars and or the moon and sustain ourselves on the moon and Mars with growing our own food. But first, Gary, tell us a little bit about where you grew up and how you got involved in this.
Well, sure. Well, I was born in Oklahoma. Grew up on. Ended up traveling around. My father was a horticulturist. My grandparents both had farms and ranches. And then we moved to Fayetteville, Arkansas, and I called that home. I graduated there and began working in horticulture, or the growing of fruits and vegetables at the University of Arkansas Experiment Station.
Razorbacks,
absolutely. And spent 2 years there. Then I went to Oklahoma State University, right across the line in Oklahoma, where I was born, and got a degree in biology. At Oklahoma State University, moved down to Georgia, and got another degree in horticulture, working on physiology at University of Georgia in Athens. And finally, I had to either get a job or go back to school. So I went to California and got a degree at the University of California, Davis in pomology, or growing fruit, apple, peaches, plums, and pears. And after that, was on the horticulture faculty of the University of Maryland for several years, teaching tree fruits and greenhouses and controlled environments. And then the opportunity came down to come down to Florida to work on a project called the Controlled Ecological Life Support Systems. Cleanest project, neatest one I ever came for. I came down for about 18 months, and I've been working in that field ever since.
Wow, what a career there. You let me ask you about your father's influence as a horticulturist.
Well,
I have never asked you about your father, if he's still around, and he's certainly got to be proud of you.
Yeah, my father was an agronomist, which means he worked with soybeans and he worked with wheat. And some of my earliest memories are when he was working on his PhD, of sitting at the kitchen table counting out heads of wheat from different treatments so he could write that up. So yeah, it was very influential in education and in research. And so he was on the faculty of the University of Arkansas. And then I began working in a different department in horticulture, horticultural food science it was, as a field technician. Harvesting, I was hoeing and picking beans in the summertime, and then we'd process them and then assess different treatments, how they did on flavor and texture and consumer accessibility as
Interesting.
as the summer went on. So
So
I
you-
get it naturally.
You go to the grocery store, you kind of have a different spin on things, do you?
I don't know if I
You
have
go
a
in the
different one.
produce section.
Oh, I love the produce section because I see all of the varieties. My youngest at the time, when I was on the horticulture faculty, he had been about 5, and he'd know the difference between different kinds of apples. So
Oh,
we know the tart ones and we know the sweet ones, and you could pick them up. So you know,
interesting.
we there's a lot of technology that goes into the selection of fruits and vegetables and that processing that doesn't meet the eye. But,
Well, we're here to talk about things spacey in food in there, but
mhm,
Gary travels the world. He's a sought speaker. Had a hard time getting you here last year as we got our new studio here. Beautiful green screen
mhm.
of some of the production of some of your food there. But he's been in Europe recently and so forth. And I know that you love inspiring kids. And we got an opportunity here at the museum to
Oh,
host a dozen Boy Scout troop from Saint
mhm.
Port St. John, Troop 475 or 479. They have girls in Boy Scout troops
They
these
do.
days, in case you didn't notice there. But you're in the same lane as us, as wanting to inspire the next generation for a great career in there are tremendous career opportunities in astrobiology and these disciplines
Right.
that you're familiar with, right?
There's incredible opportunities to take the technologies that we have, learning to grow plants in space under these unique environments, and then applying them back here on Earth. And that was really fundamentally why I started Synergy, so that I could take all of this experience, knowledge, and opportunity to do some of the coolest things on the planet as a horticulturist, but then bring it down. There's going to be some serious problems happening here on our own planet. And so, as we can take those opportunities to solve problems here on Earth, we can apply those as we explore the universe and vice versa. So, we have a closed loop system of knowledge, training, and possibilities.
So just like no dollar has ever been bartered in space, all the money's spent on Earth. Okay,
Mm-hmm.
uh, that kind of smacks with the plant technology. Is like you said, full circle is to benefit people on Earth and just not space.
Absolutely. Those investments in space feed back onto Earth, and those things that we do on Earth and inspire and inform how we're going to explore space.
Great. Well, we're looking forward to this conversation with you. I wanted to just throw out there again, we are having Shuttle Fest, and one day you're going to be a presenter there. We'd love to have Shuttle Fest focus on plants in space. Feeding people in space would be a great Shuttle Fest topic, as we're going to do these topic
Mm,
wise, celebrating the Base to Space Mobile Launch Platform 2 documentary, April 15th at the Hyatt Place in Titusville, and we'll be unleashing the public relations uh, PR on that hopefully by Friday. But
that,
I don't think you went to the last one with the Shuttle Fest one. You were out of town,
yeah, I was out of the country at the time.
but these are events that we're tailoring for you and
Right.
people in your career to have a Shuttle Fest 4, 5, or 6 might be about uh, growing food in space. Here's a blast from the past. This was our old setup here. We actually have a COVID screen between you and
Mm-hmm.
me there. Had to print out your name. All right. We dressed up our little uh, kids gallery there with the earth in the
Yeah.
back. And Marty, those were some great days in many ways. I always loved, I'm a flag waver. I had the American flag there so you couldn't see our feet underneath the table and so forth.
Yeah.
So we have come a long way. And it's only because of you out there wanting this program. Uh, every day now, I'm getting some nice compliments about how people are enjoying Stay Curious. And so tell more people. This is how we're monetizing this on YouTube, and programs like you're going to hear from Gary here are you're not going to get anywhere else. I guarantee you. We are the only ones talking on a week to week basis about astronaut heroes, new things in space like this plant technology we're going to hear about. So, but there's a look back. Wow, two
Mm.
years ago, September. So that's almost 2.5 years ago. we still look pretty good.
We still look
You
good.
know, I
Yeah.
can't count any more gray hairs because I'm all gray. But anyway, there you are, Gary. Tell us a little bit about your Synergy company.
Yeah. Well, Synergy,
Then we'll go into that.
yeah, got its name-headed series of experiments. We'll talk about them a little later, which are looking at the beneficial and mutual agreements between plants and bacteria. But really, that goes much more to the synergies between plants and people and their environment, and how we close that loop of it's not just one thing that's necessary to get to space. So we do three things. One, we maintain a laboratory in Florida Space Life Science Laboratory just at the gate of Kennedy Space Center. And in there we do our own research. We'll show a little bit of that maybe a little bit later. And then we consult with teams that are building experiments that are going to go to space or involved with creating new technologies and testing for exploration. And the third is taking that technology and applying that to growers here on Earth in greenhouses and vertical farms, how they can take this technology and prove that to secure very high and efficient yields in controlled environments for the future. So those are the three things we do on a fairly small team, but we try and stay productive and make our time and impacts count.
Mm-hmm. Well, now you're going to tell us a little bit about what you are doing, what you're looking into, and people want to know about potatoes on Mars, and how we're going to do it.
We'll talk about those in a little bit, and we got the Martian. Well, two things are going to happen in hopefully my lifetime, but certainly in the children's and in the foreseeable future. The first thing that's going to happen is we're going to go to Mars. We're doing all of the work now. We're doing the due diligence. We're mapping it out. I was here with Marty just a few weeks ago, watching and feeling the largest rocket on the planet launch. An even larger one is going to launch in a few months. We are mapping Mars. We are surveying it. We're going to be going to Mars. But at the same time, in the same period, the populations are growing, and we are going to have another 3 billion people on this planet. And that's a big number. We talk billions, but that's the population of North America, South America. They have Europe, Japan, and Australia. Those are all coming to dinner in our lifetime. And we're setting the stage now to feed them. So these two opposing forces are going to define ourselves as a space exploration species, and secondly, are going to be a existential threat and a defining moment for us here on this planet.
And at this moment, the population of the Earth is
somewhere just shy of 7 billion people.
Okay.
So we're going to have another third of the people coming to the table.
And people are living longer. We know that.
We are living longer.
Octogenarians are nothing now in our society.
Yep, we're living longer. Currently, we're about 12% of the population is over 65 worldwide. It's going to go up to 20%. So we're going to have a lot of those issues to deal with. So we have to have healthier food. We have more people to feed, and we're going to need to utilize a lot of forces coming together to use our land and our resources very efficiently in order to sustain that planet here on Earth. And those are exactly the things that we have to look at on Moon or Mars. When we go, we can't just resupply. Everything that we do is a resource. This bottle of water you gave me when we were on the way to Mars, I'm going to drink this bottle of water for the next 3 years. So how are we going to save it, recover it, recycle it, drink it, use it, recover it, recycle it? Those technologies, those demands of the Moon and Mars are going to be critical to be applied here on this planet.
course, you're referring to recycling urine on the International Space Station, which, Marty, we've heard lots of astronauts talk about that at the
Mm,
astronaut encounter, and they say it's quite delicious and the
absolutely.
best cup of coffee they've had. You know, you can't, it's actually
Yep.
purer than maybe the water in that
Yeah.
bottle.
It's not only that, you're recycling the sweat, the evaporation off of plants. All of the water that goes in eventually comes out.
Well, you're going to be telling us about
I'm going
contained
to tell you about
systems
that.
here.
That's
So
absolutely. I can talk on all this all day long on any one of these. So keep me moving.
there we go.
So,
Human life support requirements that we need to go to
okay.
Mars.
And yeah, so you've got some numbers back there, but ultimately there's four things you need to stay alive. If we keep talking and we close up these rooms, we'll have a good time, then we'll nod off and go to sleep. Because we have contaminated this atmosphere with CO2 as we breathe out, and we will fall asleep and die. You can scrub that out mechanically, and we can go a little longer until we fall asleep from lack of oxygen. So we can fix that one mechanically or chemically. We can go longer until we get really dehydrated and we dehydrate. We can do that. We can make water from oxygen and hydrogen, and we can recycle that mechanically. But the fourth thing is food. And the only way we know is a biological source of food. So in our kind of thinking, the one thing that will do all four of those life support systems are plants. They take our waste CO2, turn it into life-giving oxygen. It takes our wastewater, purifies it into water, and if we do the diodes right, we produce food. And we need a lot of it. It's somewhere about 30 kilos a day of water and food. That's almost 60 pounds. So that's 60 pounds in, 60 pounds out. A crew of four, that's I don't know, 600 tons or so. It's a lot of food, water, and supplies that if we don't recycle it, we're going to have it there in the corner of our spaceship. So
Mm-hmm. Mm-hmm.
that's
Next
what we
slide
look,
here.
biological life support. And so this is what brought me down to Florida. It was a project called the Controlled Ecological Life Support Systems, or the Breadboard Project. And that big white thing in the back was actually a pressure chamber used in the Mercury and the Gemini programs to test to make sure those capsules didn't leak. It was a hyperbaric test chamber. And it had been accessed after those programs. And then with the vision of several folks, I certainly with this museum, Al Kohler was very much involved with getting the funding for this. Paul Buchanan and several others to get funding to convert that to a life support system. So they put it on end, added in lights and a humidity system, and we began to grow plants. And the objective was to demonstrate the feasibility of keeping one person alive for 1 year using only biological life support. And at the time, it was state-of-the-art system. We had 4 levels that we were growing in, and in some ways it's probably one of the very first vertical farms in production. Not that we were trying to change agriculture or set anything. That was just the shape and the space. So we were creating out of necessity the ability to grow food and stay alive from the resources that would be available. We had that system, but that was also in our mind that analog for a spent piece of rocket, a fuel tank that we could then convert and utilize for a habitat for life support or biological food production. And we did a lot of tests over that. That program lasted a little over a decade.
And the results were, how do you characterize the results?
I think that was one of the, we had over 600 publications come out of this. This NASA technical memorandums, scientific publications. I forget the number of presentations, but it was extremely productive from a scientific and technical point of view. But overall, and if you can pop up to that next one, Marty, we'd made some fundamental shifts because I think we were able to redefine for the agricultural community what was possible. Because for the first time, there was the opportunity to control the CO2, to control the water, to give the plant everything it needed, when it needed it, exactly when it wanted it. And we had twice world record potato field yields in 2/3 of the time. At the point, we were 4 times greater than yields of wheat anywhere on the planet. There was a lot of models for growing lettuce at the time. We were 20% above that. That data is still being used in commercial models. And so there was a lot of technologies on sensor and automations and controls. But I think fundamentally, we were able to demonstrate what was possible with no new genetics, no new real biology, but applying our knowledge of plants with the tools that were necessary to go to the moon and Mars. It led us to find how much we would need and set the baseline requirements for the design of lunar and Mars bases.
Well, 30 years ago, did people pay attention to this? What industries today would you say are using this technology?
Oh, I think, this technology laid the conceptual framework for very intensive controlled environment agriculture, or in greenhouses, began pushing that harder. And as some of the technologies to grow into space in lighting systems eventually enabled the growth of an indoor agriculture and vertical farming, which were not possible before some of the technologies we tested. And so I think that there was a change in thinking because now we had possibilities.
What question, Marty, we have from our watchers here with Dr. Gary Stutte today, talking about how we're going to eat in space.
Yeah, Sue Coogan's asking, most of the experiments on growing food in space are on plants. What's your opinion on the feasibility of growing other kinds of food, like lab-grown meat, on long-duration missions?
I think that's a real possibility. I think it is something that's going to have to be looked at very, very closely. Because as we start going away for our limits of time and space and volume, there are numbers of ways that we get our food and our fuel and our calories and our health. So lab-grown meats, using mushrooms, using different types of proteins, are all going to be very much a part of a system. And indeed now NASA had put together a deep space, food challenge, looking at companies and organizations and universities, what are the possibilities for very intensive ways of growing food that you can do more efficiently and more effectively than growing the plants that I know how to do. But it's going to be a part of the solution, absolutely.
Good. Oh, great. Thank you for your question there. So we got some stuff you grew there.
Oh yeah. So once they ended the breadboard project or cells, we were very early on and felt confident that we had the knowledge necessary to begin saying we can grow plants on the moon here on Earth in a closed system. And then I got an opportunity to do an experiment very early on the space station, increment 4. I've lost track of what increment we're on now, but it hadn't been completed yet, and it was called the Pesto experiment. We were looking at photosynthesis, and its overarching gain was to look whether we could grow wheat, whether it could go from seed, we could produce water, it could get oxygen. We ran a series of experiments, 7 of them on the space station, capsules coming in, coming out. What you see back there was harvested by astronaut Dan Birch on the space station. He pulled them out, harvested, and we did a replant.
Hmm.
A beautiful piece of hardware called the biomass production system, very much analogous to the biomass production chamber, which was a very large one. Now this was a small one. So when, my narrow-minded view was I can grow things as well on the Earth in space with zero gravity as I can on Earth. I've got 2 points. Let's draw a straight line. Let's go to the moon and Mars.
All right.
It's not that simple, obviously, but
Looks good. It looks green. Green to me.
it
looks
grew
very-
as well. It grew as well in space as it did in Earth, and in some ways a little bit better. But it was
Really?
an extremely successful experiment, and somebody reminded me it had been the longest experiment that had done on space station, with the 73 days until a record was broken just last year growing peppers on the International Space Station. So I didn't realize I was setting a record, but apparently it held for almost 19 years.
Green peppers, banana peppers,
They were growing hot peppers,
hot peppers.
hot chili peppers.
Of course they were, because you lose your taste buds in space,
You-
supposedly.
yeah,
So they
you-
wanted flavor.
They
Really?
want flavor. It is a loss of, that sensory perceptions that you've heard. I know you've had the astronauts talk about it. We certainly hear about it. That as extended periods in times in space, those taste buds need more flavor. So things like Tabasco sauce and hot pepper sauce and chili, things that have some bite and flavor, gain currency and are well are needed and wanted.
Oh yeah, they take up packets of sauce from Taco Bell and stuff, and that's like currency up there in there. So did they gauge the Scovilles, the heatness of these peppers? People that love peppers out there know the
They
Scovilles,
did,
that
but I
kind
don't
of thing.
remember their numbers,
Okay.
so I don't want to make one up for
All
you.
right, don't make it went up there. We'll have you back, and you can tell us about that. Here's our beautiful backdrop here that we've got. No, go that way, Mark. There you go. That we have here in the backdrop there, and but LEDs, and I want to just mention this. Everybody knows, looking at that wheat,
Yeah.
that there's no up or down in space.
Right.
Okay, so it's growing up because of the light, right?
Because of the light. So those are the things that the challenges is in the absence of gravity. We have lots of problems. One, the seed itself or the plant doesn't know which way is up, which way is down. Water doesn't know which way is up or down. They don't separate. We call it phase separation. So what was required is that you have, if they can't have gravity, plants also perceive up to light and down away from light. So we can, instead of gravitropism, that's our technical term, we use phototropism, which way is up or down or turning with lights.
Let's look at your lighting situations there.
So we began to discover and started working very early on with light emitting diodes, or these solid state systems for light. Not so much as an alternative lighting source because it was better than anything out there, because it wasn't. It was just like an indicator light. It had very little output. We knew very little about it. But as you're going to go to Mars or beyond, the issues for space required things that were safe. And something like a fluorescent bulb or an incandescent bulb is under a vacuum, and if they break, you have glass floating around. And I don't know anybody with the experience, but I'm pretty sure nobody wants to have broken glass flying up their nose or in their ear. They also get very hot to the touch, and in cases like fluorescent lights, they're lit up with mercury, so you have some toxic gases around. And they wear out, so they need a lot of supplies. So these solid state lights, you get metal together, you run the right mix, you run electricity from it, and light comes out. So that provided us an opportunity to something that lasted a very long time, decades. They don't need replacement. They're cool to the touch because you don't have all of that heat. which meant you could get close to the plant and they
Mhm.
wouldn't break. So they were selected, and we began looking for safety issues as we began to go out into space. That had changed. So very early on, the earliest patents in the U.S. on growing plants uh, under light emitting diodes were from NASA funded research to the University of Wisconsin.
Hmm.
And then shortly after that patent was put together in the early 90s, LEDs were first grown in under light emitting diodes on the International Space Station. Technology over the past 25 years has progressed to where they've become the standards. This knowledge has enabled plants to be grown now on the International Space Station. It has created a whole new industry that wasn't possible. Of densely packed plants, we're able to understand and change the plant just by the light it sees. It's been an exciting time to be a plant physiologist if you like those things.
Absolutely. I bet many of you didn't think through the safety reasons of the bulbs and things breaking, and the LEDs were the perfect thing. And Gary,
Logistics and safety.
logistics and safety. That's NASA's mantra for sure. Gary, you commented to me one time it took 20 years for them to eat a piece of your lettuce on the International Space Station, but it looks like it was red romaine when they did.
They had it took a
August
very very long time.
2015.
2015 for NASA to approve it. Now, having said that, on the other side of the invisible line, on Mir Space Station, and on the Russians had been eating food that they had grown for many years, and sometimes serendipitously. But it had been a process of identifying the ability now that what you just see back there with the veggie experiment demonstrates that you can live and grow plants in that open environment with all of that other automation, that engineered environment that brings a bit of biology and light and sights and smells of earth to a very alien and artificial world.
How important do you think that is? The sights and smells, and to look at a piece of lettuce or an apple after 6 months to Mars, and you still got 3 months to go.
That's an extremely hard question to answer, but the anecdotal evidence is it's incredibly important. That what is certainly looked on the resupply missions, there is a resupply of fresh fruits and vegetables,
Mm-hmm.
which are looked forward to.
Right there at the front when they open it up, there's the goodies.
They come and the
right?
first thing they do is play with their food, then they eat it.
We've got a supply launch next week to the
Yep.
space station here from the coast.
And there will be some fresh produce on that. There has the experience and feedback we get are that the plants are a place where individuals go and they focus on. Now, on the analog missions here on Earth, we get a little more detail back because from the astronauts who can only say so much. But on the South Pole, the analog systems, there's sign-up sheets where people will spend time in around those plants because it's the only spot where you get the bright lights, the humidity, those smells. It is in an area that's very well deeply isolated, deeply deprived of sensory deprivation.
Uh-huh.
This biology becomes the social and focal point to help maintain that coping. And I'm a plant biologist. I don't.
And re-energize, because I wanted to
Right.
ask you, I mean, how, a little plant on your desk at work makes you happy, I get, and so you're saying that the people that on these expeditions to
Right.
Antarctica, we need to pay attention to that because
We need to pay attention, and those things are now being assessed. They're being looked at on the International Space Station. That psychosocial benefits of plants are now becoming, an area of research and of questioning as humanity begins to look at moving out of low Earth orbit to longer explorations and into deep space.
Well, I'm enjoying this conversation with Dr. Gary Stutte. I mean, psychosocial. That's
a big word. I know.
That's an interesting concept for sure, and I think you all can feel it out there, and that in your own personal life. For example, I love the month of May because I love laying on a green grass somewhere, looking up at the blue sky and the cumulus clouds. I love to do that once or twice in May. Just spend some human time on our environment. Marty, we've got a question from one of our Stay Curious watchers.
Yeah, Gary Gerald's asking, do you think there will be any disease threats to plants grown in the controlled environments on the space station or even future outposts on the moon and Mars? And if so, would it be the same diseases found on Earth in greenhouses and regular row crop applications?
Great question. Gary Gerald is a peanut farmer in Collins, Georgia.
All right. Yeah, there would definitely be issues that are going to come up from diseases and pests. Probably not so much pests, but diseases, and those are things that
Martian flea would be fun to find out.
They would be fun to find.
Martian little potato bug or something.
So the things that we don't know, and this is a very good transition question to some of the things that we work about in our lab. Is where are those diseases? How do you maintain some sanitation? How do you prevent those diseases from occurring? In many ways, it's going to be impossible to keep organisms away because we're going to have humans coming with us, and as try as we might, we're carriers of stuff, and the biology finds a way to find this niche. So how do we get this balance? And as a biologist and as a plant biologist, is the best defense is a good offense of having a healthy, maintaining the growth of plants nice and strong. So when that insult comes, when there's that attack, the plant can survive it and doesn't collapse. Now there's a lot of technology on early detection. How do you control? How do you cull them out? But one of the primary issues with synergy that we began looking at was the use of beneficial microbes. Synergies are mutualisms, and these microbes will form beneficial associations on the roots, and when that bad guy comes in, can fight them off. And they will also promote growth and get better utilization of resources. So between the synergies and mutualisms, we build an ecosystem where we have the people, we have the plants, and then we have that invisible world of the microbes that are protecting the plants, that are going to be protecting us.
Seems like in battle, great question, Gary Gerald. In battling any types of diseases that would go to a plant, you might create a whole new group of pesticides or herbicides that would be later applied on Earth.
Either on Earth, and there's lots of interesting things that we began to look at. So as we go beyond one plant or two plants eating, how do you put together this mix so that you have, as done as in a lot of organic agriculture here on Earth, mixing the plants that are reduce the growth of this organism that promote that one. How do you get that balance for that whole producing plants that can produce our health, keep us healthy and safe, and also maintain the health and safety of the overall population?
How's the data been so far on diseases and the food that's been grown on the International Space Station?
It has been troublesome, to be honest. There are been many efforts we've come in with this philosophy that microbes are bad, so you try and sterilize everything. So when an insult comes, they have no competition. So for many years, we were seeing that there in space and on the space stations, organisms that were normally not too much of a problem would show up on Earth, would now grow much better. We found on some diseases that they're more harmful. They're more pathogenic. So that's not a promising sign. On the other hand, some of our work with synergy, when we sent these beneficials, they became, for lack of a better word, more beneficial. That they were able to grow faster, have stronger benefits once we got back on Earth. So where that dynamic is in getting the control to making sure our soil's not too wet, it's got enough oxygen in it, that the nutrients are available, that we're able to prevent those diseases from primary or secondarily showing up. But it's a challenge. It's a real challenge.
Well, we're enjoying this conversation with Gary Stutte. Marty, we have any other questions? Okay. To go to this segment of your talk here, natural disasters happen in thousands, like that horrible earthquake in Turkey or wherever, 10,000 people killed, and getting them food and water and so forth. That begs to Gary's technology can impact emergency vertical farming here and create food quickly for the masses.
That is one of our goals, is to be able to this technology that we call indoor agriculture, vertical farming. There's lots of names for it, but what that lets one do is go into an area with minimal water. You're recycling the water using things like light emitting diodes. You see behind us some examples I visited all over the world. We've got China, you got London, you got Korea, New York City, Panama. So we have
Japan there.
Japan. So we have an ability now to go into cities. We have to go into warehouses, to set up tents and controlled areas for the intensive production of safe food on a continuous basis. So that's what we call controlled environment agriculture, or CEA. And this technology of that stacking of plants in these plant factories simply was not possible before LEDs and the light emitting diodes let plants get so close to each other. And I'd like to believe that our early work can produce incredible yields on a continuous basis.
They're doing it in these facilities. These are pictures you've taken and visited
it's
there.
being done. It's a rapidly growing field. It is, you can get an acre of land will give the productivity of 100 acres in the field. It can do 365 days a year in and year out. But it requires close attention to that biology, the environmental controls, the viewer's earlier questions of pest management and disease. How do you exclude them? So that kind of agriculture that we're practicing and learning here on Earth is a direct application of what was being developed so we could learn how to live and work in space. Now, what I would envision that our knowledge of what you're seeing on those pictures will be applied, and those lessons and those technologies of automation, control, sensors are going to enable us to have those factories on the moon and Mars.
These factories could be on the moon and Mars like that. And it kind of comes to my mind that the Joe and Jane America out there thinking about plants being grown indoors. Cannabis industry is pretty active in that, and it's growing. What do you feel about that? Using your technology, right?
As it became legal, which innovation. It has also been an early adopter of innovation.
So cannabis, radishes, lettuce, onions,
Tomatoes,
tomatoes
peppers.
can all
Yep.
be.
Yep.
Can you name us any companies that are being known now for like their hothouse tomatoes or things like that? That's
Oh,
been a long time. The tomato
that's been a
industry's been a
long,
long
long
time.
time. So
You're
you here out of Florida, you've got village farms. You've got what we saw back there. Arrow Farms is out in Newark. There's Green Sense. There's I don't want to keep going because I'm going to leave some friends out.
Well, I guess my question would be, Gary, would we be surprised at how much food and produce that we are eating that we don't realize is grown indoors?
You would.
Yeah, we would, huh?
You'd be surprised at either out of a greenhouse or out of indoors. At this point, I think it's about 50% of the tomatoes come out of hydroponically out of greenhouses. Lettuce, I don't know the percentage, but it's more than you think.
That's what we're looking for. So
Yeah.
we hear California produce, Florida produce, outside sunny stuff like
Right.
that. 50 years ago, that might 50 years from now, that might not even be a factor.
Well, it's going to change. Nutrients, we've got water issues, we've got climate change issues, we have nutrient availability issues, we have land pressures, which are going to force that agriculture production indoors and more intensive to feed the 3 billion people that are coming to dinner. The decisions we're making today are going to be implemented by my children and grandchildren, because they're going to have to use the technologies that are laying the groundwork today or what are going to be implemented.
Fascinating. I'm enjoying this, and I know you are out there. Marty, we've got another question.
Yeah, we have a question from Sharon Space Coast. Do you have to pressurize the growth chambers on the moon or Mars?
Great question. Do you have
Right.
to pressurize your growth chambers for what atmospheric pressures?
That is a really good question. The answer is yes. And that becomes down to physics. As a biologist, I had to learn a little physics. But as the pressure goes down, the boiling point of water goes down. So at really low pressures, you just boil the water off and they dehydrate and you get freeze dried. So what we have done is a whole series of experiments that worked with colleagues out at KSC and at University of Guelph in Canada at how low can you go? And so the pressures, that we want to get less and less pressure because, well, you don't want to explode the place that you're living. But we can go to about a third atmosphere of what you would see here on Earth at a minimum really is necessary to keep plants alive. So you can still have the water flow through, and they seem to do just fine. That's also an environment that people can survive in as well, as long as we maintain that oxygen. So as a general rule, if we can keep people alive in it, I can keep plants alive in it.
Excellent question. Glad everyone's enjoying this. We're winding up our conversation with Gary Stutte here. We talked a little bit about microbes in space there. You have a...
No, I am. So this is the namesake of my company, Synergy. And we've had a series of 3 experiments on the International Space Station. One was funded by NASA, one was a joint with state of Florida, and one completely private. And so what we have done is taken plants and microbes that are beneficial, let them grow together, and then as they began to bring them back to Earth and see if we can apply them to Earth applications. How we can use that unique environment of space that making the good better and keeping it on Earth. And using this particular platform, this unique environment that we have access to at a level never before in the history of humanity for the betterment of humanity.
So how do you get an experiment on the space station? Years in advance of applying and things like that?
There's years in advance of applications. There is identifying, what the question is. who is interested in it. There are multiple growers, multiple organizations that facilitate launch. The ISS National Laboratory is, a beautiful, threshold there to be able to get access. And many of these smaller experiments can go up. And as we brought those back down, you can, we've had some organisms that, we've grown our living logos with, and we're seeing, effects that are 20 to 30% greater than if we're growing under the best conditions here on Earth. So that is what we're trying to do. Use that space availability, that environment of space to improve life on Earth, and then we move that from Earth back to space.
Great. Another question, Marty?
Yeah, Z. Gubin's asking, I think no experiments so far grew food in space under direct sunlight. All were grown under artificial light. Do you know the reasoning for this?
Great question.
No,
Why not use the sun that's right there?
That's a really good question, and they've been growing under electric lights. I'd say it's perfectly legitimate. It's not artificial light. We're not growing artificial plants. But
Okay.
what we do have is real light coming from electric sources and not the sun. And the reason for that are twofold. One is just the dynamics of orbit. You'd have to be located at that portal and taking off the view of the astronauts. But if that's focused, you've got light on, 90 minutes on one orbit, 45 minutes on, 45 minutes off, 45 minutes on, 45 minutes off, 45 on, 45
Plants
off.
wouldn't like that.
They can survive on it, but they don't thrive on it. Although we've done a lot of experiments on Earth on how that would work. The second is far more practical on the harsh environment of you'd see in Moon and Mars, because once you get outside the Van Allen belt, you have a lot of cosmic radiation coming down. So the environments that we would have are harmful to humans, but also potentially be damaging to the plants. So most likely, we will have structures that are under the surface protected by regolith or something to protect us, and the sunlight would be able to be brought in maybe through pipes. But let's say you're going on the moon, then you've got a photoperiod. You're going to have 14 days of continuous light and then 14 days of continuous darkness. If we go to the Mars, we're very much like a 24-hour, more or less, but the light's about half of what we have on Earth.
Mm-hmm.
So on Mars, it's a real potential, but where we're at now on an orbiting platform or the moon, we're depending upon the electric sources of light. A good question.
A lot of people have some good
Yeah.
questions and enjoying this program, including Gary Jarrell we talked to.
Yeah.
Cliff Watson is in Pomona, Australia. He's having his brekkie there on Wednesday morning. Doug Force is in Los Angeles. Bill Whiting, thank you for 50 stars. We are getting a check for your stars, by the way. We got $80 for a full month of stars, I think, or a quarter of stars. But and that goes to our Stay Curious Fund here. Thank you, Bill. The Code Blue Collective is watching. Carlton Bailey from his hacienda. Sharon McDougall. Hey, Sharon, suit up for Shay. There's Sharon's little book there.
Oh, very nice.
Suit up
very
for
nice.
Shay. She's a great friend of the museum. She was down there in the Moritami area of south of here.
Okay.
You know those gardens down there, the
Yeah.
Moritami Gardens? I've been
Very
there.
nice. Yeah,
I love-
beautiful gardens.
They are
beautiful gardens
beautiful.
down there.
Outside of Delray Beach there.
Delray, right.
Down there. Good that you're staying curious, Sharon. Tom Usiak's watching. Hey, buddy. Hazel Banks. I saw that beautiful lady today in our museum. She was doing the rack cards up and down Cape Canaveral today. Zubin is watching. Of course, that's Rock Keats. He is a 24-year-old engineer working for ESA in the Artemis program.
Excellent.
Steve Hammer's watching. Ophelia Sauterelle in Paris, or outside, she's in Normandy, France, actually. I think.
Normandy.
Christina Smith, Brian Huber, Dave Stangy's here. You
Yeah,
know
they're all
Brian?
good. I know Brian. He
Thought
just
you might have a few friends
yeah,
watching
yeah.
today.
Brian just up in North Carolina. Just took a job and is a good friend of space.
Faith
Grows amazing
Powers.
in Faith. Absolutely.
You know
Glad
Faith?
I know Faith.
Rainus.
Yep.
Sharon Space Coast, and Larry Pusker's watching. We might see Larry in our studio here with Dave Stangy. They're Michiganders that are roaming around here at spring break,
All right.
and they're threatening to come to our studios on Thursdays. So,
Well, hopefully they make it.
yeah. Well, I know you've all enjoyed this. We've got another question there as we look at. Well, Gary's going to tell us about this in just a second. Go ahead, Marty.
Z. Gubin again. How do you monitor radiation? Doesn't radiation alter plants' genome in a way that could harm astronauts if they'd eaten it?
Radiation in plants, if the astronauts eat it, can it be harmful?
As a general rule, what the radiation does is damage the tissue and kills it. So it is not a change in what the compounds are or what they look like, but it does damage. What we actually think is as we start beginning to have plants, they're very much adapted with all of these sort of pigments that you have and the colors, or their protection against radiation. So as we grow these plants that can come into the astronauts and they're in our blood system, they provide the biological countermeasure to that radiation protection.
Good, great question there. What are we looking at here?
That is one of the analogs sites that is at the University of North Dakota in Grand Fork. In every year they have a series of analog astronauts that go in and begin seeing what it's like to live and work in this harsh environment. And we began working on an experiment with them on how you could grow plants or recycle those, reuse those, and how we could potentially use things that are on the moon or Mars. In this case, the nutrients from Martian regolith, or that's the fancy name for Mars soil. And we began looking at some biological solutions to release the nutrients from it, utilize the waste that's produced by the crew to grow food.
Interesting.
And we were very, very successful in our early attempts. We see behind my head nothing except the logo. Those were plants. Those are little lettuce. We germinated in. There we go.
Yeah.
There we go. Move out of the way. Not a lot to see. We were growing in the regolith with different treatments. Nothing grew.
Simulated Martian soil.
Simulated.
You know all the goodies to put it in.
Simulated Martian soil. It was actually developed just up the road here at the University of Central Florida.
Oh, really?
And then we grew the plants, and we'd gone through basically a composting with worms. It's something we might want to come and talk to a different time.
Yeah, we'll have you back and talk more details
and
about this.
that was able to release the nutrients, recycle the waste that the crew was producing, and we went from nothing to about 70% of what I can do with a commercial potting mix.
Now, how about lunar soil?
We haven't done that
with that.
We haven't done with the lunar soil. We're looking forward to that. And if anybody is out there, wants to find out for the resources and funding, we will be delighted to work with you on that.
Plants in space education, hydroponic systems for classroom use.
This is an education system that I put together, and for a group. I think
there it is, just by my head. There's the whole situation there.
Situation. It was for a group that's also a friend here of the museum, the KSC International Academy. We went down to Brazil, and over a course of several days, there were 50,000 students lining up, looking at this, looking at plants. So at their request, have put together a bit of a classroom exercise that challenges students to take all these parts and pieces. They're stuck on the moon. Or Mars. Their resupply ship is delayed, and so now they build a hydroponic system out of parts and pieces, set up lights, and began growing food over this exercise.
Those Brazilians are crazy about science. Our good friend, I know you know Jefferson Michaelis
Yes.
and his foundation is part of our museum's circle
Yep.
of friends. And when he said 50,000 people, I knew it was at least that many.
It was
because
absolutely.
we did a special Apollo 11 thing for them down
Mhm.
there, and yeah, we love them down there, and they've got the astronaut. Pontus,
Pontus.
who Marcus Pontus is an astronaut that's a Brazilian senator now that promotes STEAM education.
And had been the head of their science directorate in Brazil.
You go down to Sao Paulo. Is that where you've been down there?
We were all over in Brasilia. We were Sao Paulo. We were, I can't remember.
Well, not putting you on the spot there, but look at those kids eating up something they can put their hands on that's
Yep.
science and see it grow and all that sort of stuff
Right.
there. We got one more question here for Gary Stutte, who would love to feed the world, and we're so excited that
Yep.
of the things you're doing. What's the question, Marty?
Question from Dano D'Amato. Can plants thrive with the sunlight level on Mars?
They will grow. Some of them may survive. Some we might actually be able to thrive. It's about half the light that we get here on Earth. So we will have to make some selections for specific plants that will thrive. But what that does let us do is use the sunlight that we would have on Moon and Mars and the amount that we'd need to supplement to get them to their full potential, that maximum benefit of oxygen production, CO2 removal, water production, and food and nutrition can be reduced. So once we're on Mars, we'll certainly use that resource.
Great answer. We could talk endlessly. One question I do have is seeds being customized for use in Martian regolith or the low light situation.
Well,
Can you genetically improve seeds for planetary use?
the answer is we would assume that they were, but I don't know if you realize that's a question. I don't know if you've seen those.
Oh, the
before.
Park seed that
The
were
Park
on
seed
the
They went up on a Challenger in
the long
1984.
Yep, LEDF, long exposure duration facility.
And they stayed up for several months. And when they came back, Challenger's original mission was to go back and collect them, and unfortunately that was unsuccessful.
April 6th, 84 on Challenger, and returned to Earth 6 years later on Columbia. Sweet. What is this, tomatoes?
Those are tomatoes. And when these went back to a whole series of students and college students from grade school to university and were tested, they performed as well or generally better than those that had been here on Earth.
Okay.
And so that
And why? We
we don't really know why. Perhaps the storage conditions were a little better. Maybe they like a little stress, you know, to harden them off when they come.
Huh.
But what we do know is with the existing germ
Hey, wait a minute here. Wait. Where are you going with that? Thought you were giving that to me.
I'm not giving that to you, but I tell you what, if you don't have it, the museum needs some.
Well, I've seen the packets without the seeds. I've seen that.
Yeah,
a
well,
lot
then
of those in there,
you know
so,
that's like an empty beer bottle.
That's exactly right there, my friend. Good. Marty, we have any final questions here from?
No, just Pamela Shivik just signed out. She's
Hey,
watching.
Pam Shivik. She's an astronomy Buckeye that does a lot of great outreach. Well, I hope that you've enjoyed this. It's been fascinating. Just another great guest that we've had on Stay Curious here. Tomorrow, we've got Gary Allgaier is going to be here. You've heard Gary before. He's a structural engineer. He's going to talk about building a space shuttle, the pieces and parts. You're going to be seeing it out in Rockwell. In different pictures you've never seen before. And then Terry White's going to be here with us, the OPF garage mechanic, there to talk about we're going to talk about Thursday, Gary, the first return to flight, STS-2, when Columbia did its second flight. And Terry White's going to tell us that was not as easy as they made it look, going
never
from
is.
April to November with that beautiful bird OV-102
Right.
Columbia. So, buddy, thank you so
Thank
much.
you so much.
What didn't I ask you that you'd like to share with our friends?
Well, what I want to say is, that is what we're trying to do, is using this technology to growing plants in space to keep people alive on Earth. And if there are ways that I can help you guys do it, feel free to reach out to me through this, or I'm findable.
Yep.
And
And you're not trouting the globe, sharing your expertise. So
the ability to, agriculture is changing. The face of agriculture is changing because of the work NASA has funded and supported, and it will continue to change. And that this symbiosis of going to space and solving the problems on Earth are not an either or decision. If we do one and neglect the other, we are neglecting many of our responsibilities, I feel. But they are working together. We are going to solve those two problems. We will go to Mars, and we will feed the 3 billion people that are coming to the planet.
And that's a guarantee from Gary Stutte. Gary, who's going to be the first astrobiologist to orbit the Earth? We need one, right?
Well, it's a very loose definition, and I would say we've had several up there that have been growing plants. We've had plants in space since before people have gone to space. From high weather balloons, the very first launches were having seeds. Many scientists and astronauts have worked on plants over the decades. So the definition, they are up there. They're on the space station now.
Excellent. All right. Thank you, Gary Stutte, for your expertise as space biologist and a friend of the American Space Museum. Marty, thank you for a great Streamlabs job today. Anything we need to share with our friends out there?
Nope, we're good to go.
All right, we're good to go, and you're all good to go. We appreciate Gary so much, but we appreciate you for taking your time to watch this humble video podcast, and tell your friends that this is one place where they'll get some fascinating information that they can't get anywhere else. So I'm Mark Marquette, saying that we can't wait to see you tomorrow to talk about building a space shuttle, all to bridge the space between us.